Namaste. We have previously learnt about a form of energy that was light. In this module, we'll be learning about another form of energy, and that's heat.
Yes, the concept of heat and temperature play a very important role in our day-to-day life. If you ask me, I always like to drink my coffee hot. And children, you always like to eat your ice creams cold, is it not? Yes. And if you look at news, the daily temperature play a very important part of weather report. And based on the weather report, we always decide what type of clothes should we wear and what kind of plans should we make for that day. Do you know who first spoke about the concept of heat, Chandra?
It was James Prescott Joule, an English physicist who first studied the nature of heat. And this study led to the law of conservation of energy, and by this he stated that heat is a form of energy, and like other forms of energy, it can be converted from one form to another form.
Yes. For example, in our kitchen, daily we use LPG gas, which is a form of chemical energy, and this energy is being converted into heat energy, and that's how we cook our food. Similarly, heat energy can also be converted into another form. For example, in steam engine, heat energy is converted into mechanical energy. So, let us learn about heat and its effect in detail in this module.
So what will we be learning here? We will be learning about the sources of heat. We will be able to identify hot and cold bodies. We will learn about the flow of heat energy, the concept of temperature, distinguishing between heat and temperature. We will learn how to measure temperature and the scales that we use to measure them, and the different kinds of thermometers that we use.
Let us see some of the important sources of heat. The most important source of heat is sun. Do you know how far sun is from the earth? Yes, it is 150 million kilometers away. Even though it is quite far from the earth, we are able to get the heat energy which is sufficient enough for the sustaining of life. Have you ever thought what will happen if there is no sunlight? The earth will freeze. There will be no wind, no oceans, no currents, no formation of cloud. So, we can understand how sun is the most important source of heat energy by performing an activity. What do we need for this? Let us take two mugs or bowl and name it as A and B. Fill this bowl with water and place it under sunlight for nearly 2 hours. Now, fill bowl B also with the same amount of water, but this we will place it under a shady place for the same time, say 2 hours. After 2 hours, when you touch bowl A, what do you find? You find that bowl A is made up of steel and metals are good conductors, so it is hot. Right? Bowl B, because it is also made up of metal, but it is not hot as bowl A. Why? Because bowl B is placed under a shady place. There is no sunlight. So from this experiment, we can conclude that sun is a very important source of heat energy. Now, we will do another activity to say that sun is an important source of heat energy. For this, we need a magnifying glass. Now, take a magnifying glass and place a paper. This experiment has to be conducted under the guidance of your parents. Please go to the terrace, and especially during afternoons where you see that sunlight is just on the center, right? And place the magnifying glass and place a paper below it. Now what happens? Sun's rays from very far, you know that we get parallel beam of light, and these rays will come and hit the magnifying glass. Now what happens? After hitting the magnifying glass, you see that these rays converge at one point, right? When they converge at this point, keep it for some time. You see slowly the color of the paper changes first to brown, and then you see fire starts. So this also proves that sun is a very important source of heat energy. Yet another source of heat is friction. Now, rub your hands nicely and place it on your chin. What do you find? Yes, it is hot, right? So, friction is produced when two surfaces rub against each other. So, this is a very important source of heat energy. This was discovered by primitive man when he rubbed two stones and produced heat. After discovery of this, he was able to cook his food and eat it in a better manner. So, friction is another source of heat energy. The third important source of heat energy is fossil fuels. Example for fossil fuels are coal and petrol. Let us take up coal. Coal is a very important source of heat energy. This is used in thermal power plant. For example, in Tamil Nadu, we have Neyveli Lignite Corporation, whereas coal is used as an important source of heat energy to produce electricity. What happens there? Large amount of coal is burnt, and the heat energy that is produced as a result of burning coal is used to activate the turbines, which in turn generate electricity. So, we have understood that fossil fuels are an important source of heat energy. Right. The next important source of heat energy is wood. When we go on trips, especially to Ooty and Kodaikanal, every evening they arrange for a bonfire. You can see that a few pieces of wood is burnt and people will sit around that and have fun. Now, here wood produces heat energy which keeps them warm, and that is why bonfires are organized during the trips. There are many other sources of heat energy. For example, electric heater. Here, the electrical energy is converted into heat energy. Where do we use electric heaters? Especially in places like Kashmir, where the temperature is very low, the rooms are heated using electric heaters. And microwave ovens. I'm sure many of you have come across this microwave ovens where you make popcorns, is it not? When you come from home, when you come from school, when you are feeling hungry, we use microwave ovens for making popcorns. Here, you see that heat energy is used for cooking your popcorns. So, these are some of the important sources of heat energy.
Well, in our daily lives, we encounter a lot of objects which are hot or cold. Okay, so let us see, for example, what would you expect this liquid in the cup to be? I think, well, it's a hot cup of tea or coffee, and that was pretty easy to identify for all of us. Okay, now let me draw this. Okay, now what is this? An ice cream all of you enjoy eating. And what would you expect this to be? You are right, it's cold. So in our daily lives, we come across so many objects out of which some may be hot, some may be cold. And now let us look at how do we come to this conclusion that this is hot and this is cold? Well, you would tell me that if you touch this cup, you would feel warm. And the moment you think about ice cream and licking it, you know it's cold. So what is it that is giving you the sensation of this being hot and this being cold? It is your touch. So when do you feel that an object is hot and when do we feel an object is cold? Let us look into it. So when we touch, this may be our hand, and when we touch, it is going to give us an idea of hot or cold. Basically what actually happens is that when heat energy flows from another object to us, we feel hot. So when heat flows into the human body, into us, we feel the sensation of heat and we come to the conclusion, oh, this object is hot. And what about the cold ones? Well, does cold flow? Well, cold does not flow. It's heat that flows, but here in the reverse direction. So what do you think here is, what would be happening here? You are feeling cold. So this object has drawn heat away from your body. So here, heat is traveling. Cold never travels. Heat travels from our body to the object. So here the direction of heat flow is from the warmer object, which is incidentally our hand, to the colder one, which is the ice cream, and hence we feel that the ice cream is cold. So this leads us to an important conclusion that heat flows. And let us now try to see this with the help of an experiment. So let me give you an activity which you can easily do at home. Open your freezer and take out a few ice cubes and keep them on your hand. What do you think will happen? Well, you might be thinking that's the simplest question. Of course, the ice will melt. And what about you? Will you feel cold? Yes. So could you tell me why this is happening? Yes, you're right. The ice cube, which was very cold, has taken the heat away from your body, which is why you are feeling cold. And what about the ice cube melting? Well, the ice takes up the heat and changes into liquid. This helps us to clearly understand that heat flows from hotter to a colder body. Now let us also try to see this with the help of another experiment. So for this we will be taking a beaker with hot water. So this is my beaker with some amount of hot water. And I lower this beaker into a bowl which is containing cold water. So this water here is cold. And yes, you may add a few ice cubes here if you wish. So this would make the water really cold. And we wait for some time, maybe around 5 minutes. And after that, if you dip your finger here, you would find this water would have become a little cooler. And interestingly, the ice cold water has become warmer. So what do we conclude from this? That heat energy flows from one object to another. So heat flows from a hot body to a cold body. So this is an important conclusion that we have about heat energy. Now children, let us look at another aspect of heat. Well students, Now let us find out whether our sense of touch is reliable. Now till now we had been touching all objects to find out whether it was hot or cold. But that is not a very good method, because touching every object which we are unaware of whether it could be hot or cold could give us a nasty burn at times. And on the other hand, we will also try to see whether the sense of touch is reliable, whether it gives us the correct information regarding how hot or cold an object is. So for this, we will be having a small activity where we are using 3 beakers and some water. So here we have beaker A, beaker B and beaker C. So this is A, B and C. In beaker A, we have some hot water. In beaker C, we fill it with an equal volume of cold water. And the beaker in the middle, that is B, we pour in half quantity of hot and half quantity of cold water, so we will be getting lukewarm water. Now that our setup is ready, let us start. Let us dip our finger in this of our left hand, and the other hand we dip in this. So simultaneously we will be dipping one finger into the hot water and another into the cold water. So what is the information that you will be getting from your skin? That this beaker A has hot water and this one has cold water. We keep our fingers in this water for some time. Be careful not to take too hot water. Now after some time, we dip both our fingers into the middle beaker. And now let us wait for some time. Well, we had one of our fingers in the hot water and another here we lowered our hand into the cold water. Now, when we put both our hands into this, let's see what happens. Do you know, children, what you will feel? Well, the finger which was in hot water, now in lukewarm water, you will feel the water is quite cold. And the finger which was in cold water, the same finger is going to find this water quite warm. And that is going to be confusing, because one of your fingers will be giving you the information that the water is hot or warmer than what it is, and the other one will give you the information that the water is a little cooler. So what do we conclude from this? We conclude that sense of touch is not a reliable way of finding out how hot or cold a particular body is.
From this experiment, we understood that sense of touch is not a reliable source to measure heat. Then the question arises, what is the reliable source that we can use to measure the amount of heat? Yes, it is temperature. So, temperature is a reliable source to measure degree of hotness or coldness of a body. How to measure this temperature? We can use an instrument called thermometer. So, thermometer is an instrument which is helping us to measure temperature accurately. There are different types of thermometers which we come across in our day-to-day life. Some of them are, number 1, clinical thermometer. Number 2, digital thermometer. Number 3, laboratory thermometer. Number 4, infrared thermometer. Right? Clinical thermometer. So, this is a clinical thermometer. This thermometer is used by doctors, especially in the hospitals and clinic, to measure the body temperature of human beings. Here, the liquid we use is mercury. But we all know that mercury is a toxic liquid, and we are finding it very difficult to dispose this when the thermometer breaks. So, nowadays people prefer digital thermometer. What is special about digital thermometer? A digital thermometer is not using mercury to measure the body temperature. So, this is the highlighting point. So, since no liquid, especially mercury, is not used, people prefer digital thermometer to measure more accurately the temperature of human body. Next thermometer which we are going to see is laboratory thermometer. This laboratory thermometer is a thermometer used in labs to measure the temperature of other objects. Here we are having two types of laboratory thermometer. In one thermometer, mercury is used as a thermometric liquid. We all may wonder why mercury should be used as a thermometric liquid. Let us find out the reasons. First one is, mercury is the only liquid metal because of its shiny nature, and because it is existing as a liquid at a room temperature, mercury is used as a thermometric liquid. Number 2, it is opaque, so we are able to see it through the glass nicely. The third point will be, expansion of mercury is very uniform. So, mercury expands uniformly even for a slightest change in the temperature. Therefore, very accurate measurements are possible. Because of all these reasons, we prefer mercury as a thermometric liquid. The other thermometer which we use in the lab is an alcohol thermometer. So, alcohol can also be a thermometric liquid. Now, we may wonder why alcohol is used as a thermometric liquid. Number 1, it is less toxic. When compared to mercury, alcohol is less toxic. Number 2, it is cheaper. When compared to mercury, alcohol is cheaper and it is brighter, and we are able to read the temperatures more accurately. But thermometer which contains alcohol cannot be used for measuring higher range of temperature. What is the reason? The reason is the boiling point of alcohol is very low. So, why we cannot use alcohol for measuring higher temperature? Reason is boiling point is very low. So, when compared to mercury and alcohol, mercury is more preferred because it is used to measure temperatures of wider range. Very commonly, we come across infrared thermometer. This kind of thermometer is very common nowadays. Before you enter school or mall or any public place, you can see that people use this kind of thermometer to measure the temperature. Here, the electromagnetic radiations are used for measuring the temperature, and it is a contactless thermometer, so it is more safer during this pandemic period. And the next type of thermometer which we commonly find is 6's maximum and minimum thermometer. thermometer is used to measure the temperature of a place. In the news we commonly hear during the weather report, the maximum temperature recorded at a particular place, the minimum temperature recorded at a particular place. How do they measure? They use the 6S maximum minimum thermometer to measure the temperature of a particular place. So these are the different types of thermometer which we come across in our day-to-day life.
We have just had a look at the different kinds of thermometers that we use commonly. Let us now have a look at the kinds of scales of temperature that we use. Now children, as you are well aware, if I ask you to measure the length of, say, a chair or a table rather, then what would you choose to measure it with? A scale, which is a ruler maybe, or a measuring tape, and you will express it in either centimeters or meters depending upon what is the length that has been asked to be measured. Similarly, if I ask for say a bottle of water, then you are likely to ask me, ma'am, is it a half a liter bottle or a 1 liter bottle? So for these quantities, we always have a unit. So the scales of temperature refer to the units that we use while expressing temperature. So we have three major scales that are used. The first scale is the Celsius scale, and the Celsius scale was given by Anders Celsius, a Swedish astronomer. The Celsius scale is also known as the centigrade scale, and in the centigrade scale we have the lowest point, which is called the lowest fixed point, as 0 degrees Celsius, and the fixed point, which is the upper fixed point, is taken as 100 degrees Celsius. And I repeat, it was given by Anders Celsius, a Swedish astronomer. The next scale of temperature that is also in use is the Fahrenheit scale. Well, the Fahrenheit scale was given by Daniel Gabriel Fahrenheit, a scientist who is also known for his contribution towards making the alcohol thermometer and the mercury thermometer. So he devised a scale of temperature which has a lower fixed point at 32 degree Fahrenheit and an upper fixed point of 212 degree Fahrenheit. Now the Fahrenheit scale is more commonly used in the United States. In India, we use the centigrade scale more often, which is also the Celsius scale. Moving on, we have the third scale of temperature, which is primarily used by scientists. When you listen to the weather report or temperature readings, you will rarely hear of any temperature being expressed in Kelvin, which is my third scale that is usually followed by scientists. So, it was given by Lord Kelvin or William Thomson, who went on to be ennobled and referred to as Lord Kelvin. So, his scale of temperature, you have the lower fixed point at 273 Kelvin and the upper fixed point at 373 Kelvin. So, I repeat, these are the three scales of temperature that we will use. The Kelvin scale is primarily used by scientists. The other two are commonly used. In India, we use the Celsius scale very often, and Fahrenheit is more commonly used in the United States. Well, now that we have had a look at the different scales of temperature, let us see the range of each scale. So, as we can see, the Celsius scale starts at 0 and ends at 100 degrees C. So, the range of this scale is 100. So, there are 100 divisions between 0 degree and 100 degree. Similarly, this one starts, which is the Fahrenheit scale, begins at 32 degree Fahrenheit and ends at 212 degree Fahrenheit, which has a range of 180 divisions between the lower fixed point and the upper fixed point. So this is about the Celsius and Fahrenheit. The Kelvin scale has again 100 divisions between the lower and the upper fixed point. kindly note that generally for Celsius and Fahrenheit we always express it as degree C and degree F. In case of Kelvin, we do not use degree. We write 373 Kelvin. Now that we have had a look at the scales of temperature, we will be having a detailed look into a clinical thermometer. Now let us have a look at the details of a clinical thermometer. So a clinical thermometer essentially has a long, thin, narrow glass tube. So let us have a look at it. A long, thin, narrow glass tube, one end of which is expanded into a bulb. The bulb is filled with mercury, and mercury can be seen rising as a thin thread in the tube. This tube is also known as a capillary tube because it is so thin. So I'll be labeling the parts. This is the thin tube. This is the bulb which contains mercury, and this is the column of mercury that is visible from outside. Now this is encased in a glass tubing. And on this we have graduations where the temperature is expressed in either degree C or degree F. Some clinical thermometers have only the Celsius scale. Now you may be wondering what are the markings on the scale. So the range of the thermometer is from 35 degrees C to 42 degrees C. Human body temperature never falls below 35 degrees C, or neither does it rise above 42 degrees C, and hence these are marked as the extreme points. The lowermost point is taken as 35 and the upper point at 42 degrees C. Normally, the human body temperature is around 37 degrees C. So this is an average normal body temperature which is 37 degrees C. Now the next thing that we are going to learn here is how do we read the temperature on this thermometer. So let us take for example just the scale. So let us take two big divisions as the longer marks. This as 35 degrees C and this one as 36 degrees C. And let us have smaller divisions here. So 1, 2, 3, 4 and the fifth division is again the longer one. So here what can we say? That each small division corresponds to 1/5 degree. So that is equal to 0.2 degrees C. So with the help of this, we can easily read the rise and fall of the mercury column. So if a person has fever and we put this bulb inside the mouth and wait for some time, mercury being the good thermometric liquid that it is, it will expand and rise to a particular height. Once it rises to a particular height, then we can easily read the temperature. Now this brings us to an interesting feature which we find in clinical thermometers. Now you would wonder that if I take this thermometer out of a patient's mouth, shouldn't the mercury just fall? But here it does not, because there is a small bend in this capillary tube. This small bend is referred to as a kink in the thermometer, and it prevents the mercury from falling down on its own, thus aiding the person who is reading the temperature to have an accurate reading of the body temperature.
Now that we have learned about clinical thermometer in detail, let us see what are the various precautions that we have to follow when we are using a clinical thermometer. The first and foremost is that the thermometer should be washed before and after use. Why that has to be done? Because you know that the clinical thermometer is used to test whether a patient is having a fever or not. And while doing so, we will be keeping the bulb of the thermometer in the mouth of another person. So, we have to wash the thermometer after using it, preferably with an antiseptic solution. This will kill the germs, so that in case we are going to use it for another person, you see that the infection will not spread. So the first and foremost thing will be the thermometer should be washed before and after use, and especially with an antiseptic solution. The antiseptic solution can even be Dettol or alcohol. Right? Next, we have to ensure that before placing it in the mouth of the patient, we have to ensure that the mercury level is below 35 degrees. Why that has to be done? Because while learning about clinical thermometer, we said that there is a king. And what is the job of king? We learned that the king will not allow the mercury to fall down. So, you have to shake the thermometer and ensure that the mercury falls below 35 degrees, and then only use it to test whether the patient is having fever or not. Next, you should see how to read a clinical thermometer. So, whenever you are reading a clinical thermometer, it should be to the level of eye like this. You have to place the thermometer to the level of eye and then take the reading. Suppose you are going to place it slanting, it may lead to parallax error. So, whenever you are reading the clinical thermometer, you should see that you are keeping the level of eye to the mercury. That is, read the thermometer, keeping the level of mercury along with the line of sight. It means you have to place it just parallel, that is straight to your eyes, and you should start reading so that you don't make any parallax error. Next, what you have to handle the thermometer very carefully. Why? Because it is made of glass, and while reading the thermometer, you should not hold the bulb. This is the bulb. You should not hold the bulb and read the thermometer. Why? Because in the bulb we have mercury, and a slide, when you are holding the bulb, what will happen? Your body temperature will make the mercury to expand, and there will be variation in the temperature. So, never hold the bulb of the thermometer while reading the clinical thermometer. The last and final precaution you have to follow is that you have to handle this thermometer with care, because it is fully made up of glass and there is every possibility for the thermometer to break. And if it breaks, you know that mercury is a toxic substance. It will create pollution. So you should always handle a clinical thermometer with care after using it, and after washing it with antiseptic solution. You can use a box that is being provided for it. You can just place the thermometer in such a way that the bulb is down and you can close it. This way we can handle it with care. So these are the precautions we have to follow while using a clinical thermometer. Children, will you be able to tell me what is the average temperature of human body? Yes, you are absolutely right. The average temperature of human body is 37 degrees Celsius. Will it be same in all the cases? Let us find out by performing a simple activity. This activity you can do it at home. You can find the temperatures of your family or friends and see whether it is same. So, check the temperature of your family members and see whether it is the same. You will find that it is not same and it is around 37 degrees Celsius. The temperature varies and it is around 37 degrees Celsius. What is the reason for this? you should know that the temperature of human body varies and it depends on the age, right? And what is the health condition? And exertion level. So these are important factors which determines the temperature of a human body. But on an average, always we take the human body temperature to be 37 degrees Celsius. Now, we so far have learned how to measure the human body temperature using clinical thermometer. What about other objects? I would like to measure the temperature of other objects also. For example, I want to measure the temperature of ice, or I want to measure the temperature of hot milk. Right? What can I do? Can I use a clinical thermometer? Of course not. Why? Because we have learned that the range of clinical thermometer is 35 to 42, and hot milk temperature can be more than that. Of course, you know that the melting point of ice is 0 degrees Celsius. So, we cannot use clinical thermometer to measure the temperature of ice or hot milk. In that case, what thermometer should I use? I should use a laboratory thermometer. So now we will be learning about laboratory thermometer in detail. Now to measure the temperature of hot milk or that of ice, another alternative thermometer that we can use is a laboratory thermometer. This laboratory thermometer has a bulb which can be either filled with a column of mercury or alcohol. And here you see a very thin stem or tube which is called the capillary tube through which the mercury rises. And the lowermost range is minus 10 degrees Celsius. And the highest range will be 110 degrees Celsius. Since you see that there is a wide range of temperature, this can be used for measuring temperature of many objects. For example, melting point of ice, boiling point of water, or that of a boiling point of a hot milk can be measured using this thermometer. Now, how to use this thermometer? You know that unlike a clinical thermometer, in the laboratory thermometer there is no kink. So when you are using this thermometer, you have to always have the thermometer in an upright position. So you cannot use this thermometer in a slanting position. And this thermometer cannot be used to measure the human body temperature, because as soon as you take the thermometer out of the mouth of the patient, you see that the temperature will start falling down. And you know the reason. The reason is there is no kink in the laboratory thermometer. So the first precaution you have to take while using the laboratory thermometer is that you should always have this thermometer standing upright. Slanting position should be avoided. That is number one. Number two, let us see, the bulb of the thermometer should always be immersed in the object whose temperature is to be measured. Right? At the same time, we should also take care that the bulb does not touch the beaker. Right? So, these are the two things we should observe while using a laboratory thermometer. Now, let us perform an activity to see how to take reading in a laboratory thermometer. For this, I have set up the apparatus here. Here you can see a beaker containing water, and you see a laboratory thermometer. The thermometer I have taken is an alcohol thermometer. You can see a bright thin red line. This helps us to read the reading easily. And you see, as we have taken the precaution, the thermometer is standing upright and it is immersed well inside the water, but at the same time we have taken care that the bulb does not touch the end of the beaker or the sides of the beaker. Now this beaker is placed on a tripod stand and we have a source of heat, that is the candle. Now let us know the initial temperature of the water. You can see the red line here, right? So now let us learn how to read the temperature. This is the scale. Now in this scale, let us start from 20 degrees Celsius. Between 20 degrees Celsius and 30 degrees Celsius, there are 10 divisions. So 1, 2, 3, 4. The fifth division will be slightly longer. 6, 7, 8, 9 and 10. So now you have here 30 degrees Celsius. Our initial temperature of water, the level of alcohol has raised up to this. Now, what will be the reading? So, this is 20 degree. Each division is equal to 1 degree Celsius. So, 21, 22, 23, 24, 25, 26, 27, 28. So, the initial temperature of water is 28 degrees Celsius. Now, let us heat the water and record what is the temperature rise. For heating, let me light the candle. So, now I have lighted the candle. You see that the heat will get transferred and slowly the temperature will start rising. The water is getting heated up. You can see that the temperature is rising. Now we will stop heating water. Now we have put off the candle. Now let us learn how to read the final temperature. Our initial temperature was 28 degree and the alcohol has raised up to this level. Now here you can see 30 degree. From here let us start reading 31, 32, 33, 34, 35, 36, 37, 38. So the final temperature is 38 degree Celsius. So this is how we can measure the temperature using laboratory thermometer.
Students, we have been studying quite a bit about heat and temperature. Now, these two terms are very closely related and yet they are different. They are in fact so closely related that it is very easy to get confused between these two terms. So, we shall be trying to differentiate between heat and temperature with the help of a tabular column. So, as you recollect, what do you think is heat? Well, you are right. Heat is a form of energy. So, we can write it as heat is a form of energy. And like all forms of energy, as we have discussed previously, it can be converted to other forms or we can obtain it from other forms of energy. So, it is energy. And let us see what is temperature. So, we have temperature on this side. Temperature is a measure of how hot or cold a body is. Okay, so we can note it down as temperature is a measure of how hot or cold a body is. So we can conclude that with the help of temperature, we can get an understanding of the intensity of the heat. Okay. So let me give you an example which we use on a daily basis. Okay. So very often we discuss weather and we say, oh, it's really hot today. So when we say it's really hot today, it's a very general statement and we have no clue as to whether today is hotter than yesterday or whether being at Chennai we are finding it more hot than say another city, for example Delhi. So how do we have a concrete idea of how hot it is? So the intensity of the heat will be understood easily if we bring the concept of temperature. So that time what do we say? Then immediately our next question is, yes, what was yesterday's temperature? So probably it was at 32 degrees C and today maybe at 35 degrees C, and it is easy for us to compare. So temperature gives us the measure of how hot or cold it is, and heat is actually the energy that is causing or is being shown by this rise or fall in temperature. So I hope that clears the first point. Now, so this brings us to our second point. So heat is responsible for raising temperature. Heat raises the temperature of a body. So, when heat energy flows into a system, the temperature rises. Determines the direction of flow of heat. Now again, with the help of an example, let us understand this. So we have had previously ice in our hands which was at a very low temperature, which took away the heat from our hand and it became warmer and therefore it melted to water. So temperature determines the direction of flow of heat, whereas heat raises the temperature of a body. So you can see how closely the two are related. So we can just from a hot body, it will always flow to a body which is cold. So temperature decides from where to where it is going to flow. So for example, children, you must have seen when we have a bath, we generally will take hot water and we mix some cold water into it. Or even if you are using a geyser, we do the same thing. Whether or not you are having a shower bath, we adjust the heat because we know that the hotter water will become colder when we add water to it, which is cold. Because temperature determines that the heat will flow from hot to cold. So when two bodies are in contact or sometimes even far away, heat will flow from a hotter body to a colder body. And then we will have a look at what is the unit in which we measure heat. So for heat is measured in joules. Do you recollect what was it that we were using to measure temperature? Well, we remember the three scales: degree Celsius, degree Fahrenheit and Kelvin. So what can we conclude? That temperature can be measured in, so I will be writing units. It can be measured in degree C, degree Fahrenheit, which is air, and Kelvin. So to sum up, very simply the differences between heat and temperature. Heat is a form of energy. Temperature is a measure of how hot or cold a body is. We have to remember this particular term, which is measure. It determines how the intensity of it's a measure. So how hot or how cold a body is, a measurable value, that is the temperature. Heat raises the temperature of a body, whereas temperature determines from where to where heat is going to flow. Heat is measured in joules, whereas temperature is measured in degree C or degree F or Kelvin.
Now, let us learn about transfer of heat. Now, let us take a metal pan. So, the metal pan has a metal handle. Now, I want to heat this pan. So, I am going to use a source of heat. Now I start heating. What happens? The pan is at a room temperature. The source of heat is at a higher temperature. So heat from the body at a higher temperature will start flowing to a body at a lower temperature. So from here, heat will start flowing to the pan. As a result, after some time, I am not able to hold the pan. Right? Now I will stop heating. Let us keep the pan aside. So I am keeping the pan aside. Right? Now what happens? And after some time, I am able to touch the pan. What has happened now? The pan was initially at a higher temperature, but now it is giving the heat to the surroundings, which is at a lower temperature. So heat starts flowing from the pan to the surroundings. As a result, the temperature of pan decreases. Now the question arises, how long will that heat transfer take place? You should know that the heat transfer will take place till both of them reach the same temperature. That is, the hotter body and colder body, both of them will start reaching the same temperature. Till then, transfer of heat will take place. This transfer of heat can take place by 3 ways. Number 1, conduction. Number 2, convection. Number 3, radiation. To understand these 3 methods, let us understand it by using an analogy. Right? A boy wanted to pass a ball. So this is the boy. Okay. Okay, boy. He wants to pass a ball. Now, he wants to pass the ball. So this is the ball. He wants to pass this ball to B. He can adopt 3 methods. The first method will be the boy passes the ball to A. So the ball rolls to A. From A, so the ball rolls to A. From A, the ball rolls to B. From B, the ball rolls to C. From C, the ball rolls to D and reaches D. So the boy wants to pass the ball to D. Now what is he doing? He first passes the ball to A. From A, the ball moves to B. From B, the ball moves to C. From C, the ball moves to D. So here the ball is going to be the heat energy. Now you see the heat energy is being transferred from A to B, from B to C, and finally it reaches D. Here there is no movement. So if heat energy is being transferred without the movement of particle, then that type of transfer we call it as conduction. Now let us read how transfer of heat takes place through conduction. The analogy we are going to use here is the boy wanted to transfer the ball to B. Now initially what he did, he transferred the ball to A. From A it went to B. From B it went to C and finally reached D. But this time what he will do is, the boy D will directly come and take the ball from this ball. So what happens if the ball is going to be the heat energy is transferred by the movement of the particle. Here the particle is D, A is a particle, B is a particle, C is a particle and D is a particle. If transfer of heat energy takes place by the movement of particle, then that type of transfer of heat is called as convection. Right? Now let us see what is radiation. The boy wants the ball to reach D. So what is he going to do? He is going to directly throw the ball. So the ball is here. Directly it reaches D. He does not need a medium. here the medium will be A, B and C. Without the help of the medium, you see that the ball from this ball reaches this B by directly, that is by throwing. So, if here this method of transfer of heat where there is no medium required, such type of transfer of heat is called as radiation. Let us learn about conduction in detail. In solids, the heat energy is transferred through the process of conduction. Let us perform an activity to see how conduction takes place in a solid. For this, I have taken an iron needle. So, the iron needle, I have taken an iron needle and I have fixed it to a star. I have taken two pins and these two pins are stuck to the iron needle with the help of molten wax. Now, I am going to light candle and heat one end of the iron needle. So, here I am lighting the candle and I am going to heat one end of the iron needle and let us see what happens after some time. This experiment has to be done strictly under the supervision of elders. Now, you will notice that as soon as the iron needle starts getting heated, the pins start falling one after the another. The first one to fall is the one which is closest to the candle, and the last to fall is the one farthest from the candle. So, the transfer of heat from one end of the needle to another end is known as conduction. What has happened here? When the iron needle is heated at one end, the temperature of iron needle increases. As a result, heat from the hotter body start moving towards the colder end. This was the reason why the wax melted and the needle started falling one after another. Now, let us try to define what is conduction. The process by which heat is transferred from the hotter end to the colder end of an object is known as conduction. And we have also proved that in solids, generally heat is transferred by the process of conduction. Do all materials conduct heat in the same way? Let us find out using an activity. For this activity, we need a small bowl and we need 3 spoons. Let this be spoon A, B and C. This spoon A is made up of metal. Spoon B is made up of wood. Spoon C is made up of plastic. Now, place the spoons as shown in the figure and put a patch of butter on all the 3 spoons. Now, place a bead on top of them. So, I am placing the bead on top of them. Now, carefully pour boiling water. So, you have to pour boiling water in such a way that the position of the spoon is not disturbed. After pouring boiling water, see what happens. Now, slowly the butter in the metal spoon A will start melting. This makes the bead to move from this position to this position. The butter in the spoon A melts, because of which the bead moves from this position to this position. Whereas in the other 2 cases, the bead remains in the same place. So, what do we understand here? We understand that metals are able to conduct heat very well, because of which you see that the butter on the metal spoon melts. This has made the bead to fall down. Whereas the other 2 spools, one which is made up of wood the other one which is made up of plastic are not able to conduct heat. As a result, the butter present in them is not melting. So, based on this, we can understand not all materials conduct heat equally, and we can classify them into two types. Number one, conductors and insulators. So, what are conductors? Conductors are materials which allow the heat to flow through them. Example, all metals. In fact, silver is the best conductor of heat. Next, materials which do not allow heat to flow through them. Are called poor conductors or insulators. What is the example we saw? Example, wood, plastic, etc. Now let us see what are the applications of conductors and insulators in our day-to-day life. Most of the cooking vessels are made up of metals. The reason is metals are very good conductors of heat, and when you are using metals for cooking, the cooking time will be very less and fuel can be saved. At the same time, if you see in this pan, it has a handle. The handle is always made up of plastic, which is an insulator. Okay, so why are we using plastic handles? Because the heat gets transferred, and if you are going to touch the handle, it may cause burns. So we are using plastic handles. As plastic is an insulator, it does not allow the heat to flow. As a result, we can easily work with the pan. Next, gloves. During winter, we feel very cold, so always we wear a pair of gloves to keep our hands warm. So what happens here? Wool is a poor conductor. We know that our hand is at a higher temperature, the surrounding is at a lower temperature, so the air that is trapped in between the fibers of wool is an insulator, and this does not allow the flow of heat energy. That is the reason we are wearing a pair of gloves which keeps our hand warm. Igloo is a good example for conduction. Inside igloo we feel warmer. What is the reason? The reason is snow is a good insulator, and there are air pockets inside the snow which does not allow the flow of heat. It is this reason we feel warmer inside igloos. The next important application is birds puff up their feathers during winter. So when they do this, what happens? Air gets trapped and they feel warm. So that is the reason birds fluff up their feathers. Another application of conduction is electric iron, where the heat energy flows from iron to clothes.
Well, students, we have been learning about the transfer of heat and we had a good look at conduction. We will be coming to the next mode of transfer of heat, which is convection. In order to understand convection better, we will be performing an activity. So let us see what are the materials that we have taken or used for this activity. We have a candle which generates heat, a wire gauze and a tripod stand. I have a beaker which is having water in it, plain and simple water. Water is being heated by this candle. So now what I will be doing is, I will add a few crystals of potassium permanganate. So let us watch. Please observe carefully. Well, you can see a beautiful pink coloration. And let us observe the path of the pink color as it travels up. I hope you are able to clearly notice. The pink color is traveling up, it is rising up. So students, let us try to understand what we have just observed. We basically had a beaker in which there was water and we are heating it with a source of heat and we have water in it. We have put potassium permanganate crystals so that it is easy to see the direction of movement of water, because otherwise that is not visible. So what actually happens here is that the water which is closest to the source of fire gets heated first, and when it gets heated, the water expands. Water expands on being heated, and when it expands, water becomes lighter. So when the water has become lighter, obviously it goes up. So the hot water rises up. And then what do you think would happen? As the hot water rises up, cooler water from the sides and top come in to take its place. This in turn, the cooler water will get heated in a short while, and then it is also going to expand, become lighter and rise up. So this sets up a current inside the water. This is called a convection current. And this current will continue till the entire liquid has got heated up. And this is exactly why we see a full purple coloration in the beaker, where we had dropped the potassium permanganate crystals very carefully at the bottom. So it is basically the convection current which is carrying potassium permanganate and helps the whole solution to become purple in color. So what do we conclude from this? That in liquids, heat is transferred by a process called convection. So convection is the process of heat transfer that we have seen here, and it takes place in fluids, which is basically liquids and gases. So how can we define convection? Convection can be defined as a mode of transfer of heat energy where the particles actually move to transfer the heat. In case of conduction, the particles did not move from one place to another. But here, the particles actually move around to transfer the heat to the whole system. So it is seen in liquids and gases. As we know, solids, especially metals, are very good conductors of heat, but most liquids and gases are poor conductors of heat. So you may be wondering, how do liquids and gases get heated up? So they get heated up by convection. If you look around you, you will find that convection plays an important role in daily life. So let us look at a few examples where let us see how convection takes place in nature. So have you ever wondered why that houses which are built on the coastal areas have their windows facing the sea? Now during the daytime, the land and the sea, which are both exposed to sunshine, get heated up. But what we need to remember is that the land heats more. The land gets heated up more than the sea. So the air above the land in turn gets heated up more than the air above the sea. So what can we conclude? That the air above the land is warm air and the air above the sea is cold air. Now we know that warm air expands and hence becomes lighter. So when something becomes light, what would we expect it to do? To rise. So this warm air rises up. The warm air rises up, leaving some space here. So a vacuum is created into which the cold air starts coming. So the cold air blows towards the land because warm air has gone up. So this warm air rises up and its space is filled in by cold air. So this sets up a convection current which occurs during the daytime and it also has a cooling effect on the land. Hence, people who live close to the sea enjoy the cool sea breeze. So what is this breeze called? Since it is coming in from the sea, this is called a sea breeze. And this, as you can see, is the convection current which has been set up due to the warm air rising up and the cold air blowing in to fill its space. Now let us have a look at what happens once the sun goes down. The sun has set and as you can see it is night time now. Now at night, land which heated up faster during the day cools down also fast. So the land becomes cold whereas the sea which has taken a longer time to heat also takes a longer time to lose heat. So it is warmer now. So the air above the sea is also warm. And the air above the land is now cold air. So what do you think would happen? Just like the previous scenario, it is similar, only the directions are reversed. Warm air over the sea will now rise up and a vacuum is created here. So now, as you would expect, cold air from the land blows in to take its space. So now we have a reverse current which is set up. Now the current is from the land towards the sea. So since this blows from the land to the sea, this is called a land breeze. During the daytime, it was just the opposite. We had warm air here and cold air here, so the direction was this. From the sea towards the land. In the evening, once the sun goes down and it becomes night, cold air moves towards the sea. So this is a process of natural convection that occurs near sea coast and is one of the classic examples of convection currents in nature. Children, do you realize that when tea is made, again convection plays a role? Well, let us see how. All of us have seen tea being made at home. So, basically we are here heating the water in our saucepans or whatever it is that we make our tea in. So we are heating water over a fire. So again, the water gets heated up by convection. Now here when we add tea leaves to the water, it is a very interesting sight because we can very clearly see convection currents in this case. What we will see is that these tea leaves which have been added, because they are heavy, they sink, and then because the water here is heated up, they immediately start dancing and you can actually see them rise up. So along with the convection current, you can see the tea leaves going up. And obviously this clearly indicates the movement of the water. And as the water gets heated and moves up, colder water from the sides and above comes down to take its place, and very often you see movement of the tea leaves, and then after some time the entire water would have got the color of the tea uniformly, which shows that the convection current has been moving and uniformly heating the water. So ultimately our tea is prepared. So this is a real life example of convection that you can easily notice at home. Students, have you wondered how a hot air balloon rises up? A hot air balloon also uses the principle of convection. Now hot air balloons have a heater at the base which heats air. So again, it is warm air or heated up air. And heated up air expands, becomes lighter and it rises up. So when the air rises up, it goes up and gets trapped inside the balloon. And this causes the balloon to go up. And now you will be wondering, how does it come down? Now when the balloon has to come down, the hot air is released, cold air rushes in to fill the place and becoming heavier helps the balloon to descend. So a hot air balloon is another example of using convection in our life. And we also use ovens. Now most of us love having cakes and cookies which are baked in ovens. Now have you thought of what exactly goes on inside an oven? There is a heater which puts in warm air into the oven and the air that rises up causes the food to get cooked. So an oven is another example of how convection can help us in our daily life. Students, we have just learned about two modes of heat transfer which are conduction and convection. Now let us have a look at the third mode of heat transfer, which is radiation. Now to understand radiation, let me ask you a simple question. Have you been out in the sun? Of course yes. And how have you felt? Very warm or even very hot? Now have you wondered how does energy from the sun reach us on earth? And what is the distance between the sun and the earth? It is almost about 150 million kilometers. So that's quite some distance to be covered. Now can conduction be the method by which heat travels from sun to the earth? Or can it be convection? Well, conduction and convection would both require some particles to convey the heat. So obviously conduction and convection are not the correct answer. The way heat travels from the sun to the earth is by a particular method which is called radiation. So radiation is a process of heat transfer where heat energy travels in the form of waves and reaches from the hot body to a colder body. And the unique thing about radiation is that a medium is not required. So even in the absence of a medium, radiation can happen. So here, obviously the method of heat transfer is through radiation. Because the vast distance between the sun and the earth is empty space. Of course, there is an envelope of air around the earth, which is the atmosphere, and energy from the sun, that is heat energy, can travel through space, through the atmosphere and reach us. In fact, it is this solar energy which is the source of life on earth and keeps earth suitably warm. Now, do we have any other examples of radiation in our day-to-day lives? Well, yes. In colder countries, they use room heaters. Now, room heaters also work on the same principle of radiation because heat from a room heater reaches the people inside the room by radiation, as conduction and convection cannot occur through air because air is a poor conductor of heat, and in case of convection, the warm air rises up. So obviously, heaters work on the principle of radiation. So radiation is not only a mode of transfer of heat from the sun, but we also use it in heaters. And you might have sometimes seen that if you keep something that has been cooked in a hot pan, if you just leave it at room temperature, does it remain hot even after say half an hour? Well, no. the entire pan will become cold. So any hot body becomes cold by releasing the heat into the surroundings, and that method of heat transfer is also radiation. So all bodies in fact radiate heat. You may be amazed to know that the human body also radiates heat into its surroundings, and depending upon the ambient temperature, we feel some areas to be hot or cold or some objects to be hot or cold depending on whether heat is flowing to us or flowing away from us. All hot bodies radiate heat, and when this radiant heat falls on an object, what may happen? The heat may be reflected, it may be absorbed or transmitted. So let us look into a few applications of radiation and its principles in our daily life. So one of the ways is when we use an umbrella. When we use the principle of radiation, what we do is we effectively place a barrier between the sun and ourselves, and that is how the umbrella protects ourselves from the harsh heat of the sun. It is also known that dark and dull objects absorb more heat. Dark, dull colored objects absorb more heat, whereas light colored or shiny light colored shiny objects reflect the heat of the sun. Have you ever wondered why the houses that are built, especially in warmer areas, are always painted white on the outer surface? Well, that is because lighter color will reflect most of the heat that is there from the sun and will help the inside of the room or the house to be cooler. On the other hand, when we see some shiny objects, so shiny objects will reflect more light. So one application of that is petrol tankers are usually shiny. They are shiny so that they reflect most of the heat of the sun and therefore they don't heat up, because petrol being an inflammable liquid. And what is an application of dark, dull colored objects absorbing more heat? Well, during winters we wear clothes which are dark and dull colored. They absorb more heat of the sun and help to keep us warmer. Then what kind of clothes do you think we would be wearing in summer? In summer we prefer to wear lighter colored clothes, because lighter colored clothes would reflect most of the sunshine and hence help to keep us cooler. Let us summarize what we have learned so far.
Heat is a form of energy.
Temperature is a measure of the degree of hotness or coldness of an object.
And we measure temperature using thermometers.
There are different kinds of thermometers and 3 scales with which we measure temperature.
We also understood that heat flows from a hotter object to the colder object.
There are 3 modes of transfer of heat:
conduction, convection and radiation.
We also learnt about the applications of these 3 modes of heat transfer.
We'll be meeting you in future with some more interesting topics. Namaste.